Hi everyone, all great and children, those who are preparing for the board exam, half yearly exam, and midterm, and everything. So I already uploaded yesterday for one mark question from light chapter. So we'll continue that, and then we'll discuss about even one more question also. Okay, so one more question and two more question also we're going to discuss. So let's go to the page number one. So the first question, see till 16 we discussed from yesterday. So we'll go to the 17th question. So this following table, they show the different media and the refractive index. So what the question is, the example of medium pair so that the light speed up when it goes from one of these media to another. So when the ray of light passes from denser, that means a higher refractive, to the rarer, the low refractive, we know that speed is going to increases. So for this case, we can say the example crown glass to water. Okay, then question number 18. Find the value of angle of emergence when an incident ray makes an angle of 40-degree with the normal to the air glass interface of the rectangular glass slab. So we know that it's a angle of incidence ray is a 40-degree. So we can say that both our emergence and incidence is always going to be equal. So we can say it's a 40-degree of emergence. So then next one. Question number 90. How is the refractive index of the medium related to the speed of light through it? So for refractive index relation is what? Speed of light in vacuum and by speed of light in medium. So next one. The speed of light in a transparent medium is 0 0.6 times that of its speed of vacuum. What is the refractive index of the medium? This question will discuss at the end of the section. I will show you the calculation part also. Redraw the given diagram and show the path of the refracted ray. So you can see this refracted ray, so that it's going to be center of the optics. So then that it's passed through the center of optics, so you can see that. Next one, the same method, the redraw the diagram below in your answer book for show the direction of light ray after the refraction from the lens. So how what will happen for after the refraction of the lens? We will go and check in next page. Then we'll see that how it's happening. This is going to be parallel to the principal axis, and then the ray is going to the f2. So f1 and f2 is equal distance from the center of the optics, we know that. An object 23, an object is held at the principal focus of a concave lens of a focal length f, where the image will form. See that it's between the optical center and the focus. This is next question is like application question. A girl was playing within a thin beam of light from her laser torch by directing it from different direction of a convex lens held vertically. She was surprised to see that in a particular direction the beam of light continues to move along the same direction after passing through the lens. State the reason for this observation. So, what is the meaning? The ray of light passing through the optic center of the convex lens will continue to move along the same direction after refracting through the lens. Question number 25. They're asking the question, is it possible to form a real image using a real object with a convex lens? No, it is not possible because the concave lens always forms a virtual image. So far in 25 questions we discussed for one more question. So we're going to discuss two more questions. Number one. So we'll continue the number. So next number is 26. State the two laws of reflection of light. We already know that it's a state laws of reflection of light. The angle of incidence is equal to angle of reflection, and the incident ray normal to the reflecting surface at the point of incidence, and reflected ray from the point all lies in the same plane. It's complete. You have to write in exactly same, then you will get a full mark. And next question 27, in characteristics of image by a plane mirror. It's very good question. It's always virtual and erect, and the size of the image is always equal that of the object. An image is formed at the same distance behind the mirror as the object in front of the mirror. An image is laterally inverted. Question number 28, the magnification of plane mirror is plus 1. Where does m is equal to 1 and positive sign signi? And then the magnification m is equal to 1 shows that the image is exactly of the same size that the object, while plus sign indicates that the image is virtual and erect. So why does a ray falling normally on a plane mirror retrace its path? When a ray falls normally on a plane mirror, the incident angle is zero since the reflected and the incident angle are equal. The reflection angle is also zero, so it resets its path. See, next question is completely direct question. Define and show the diagram. You have to the two terms, the aperture and radius of curvature. See that it's a aperture is the diameter of the reflecting surface of the mirror, and the radius you already know the reflecting surface of the spherical mirror part forms a part is the radius of the curvature of the mirror. We'll go and discuss to the next page. So that it's the next page. Let's see the next page. Wait for a minute. We already discussed the two pages, and then we'll go for the next page. So the question number 31. Let's for properties of the image formed by the concave mirror when object is placed between focus and pole of the mirror. See, it's going to be behind the mirror, going to be enlarged and virtual and erect. Question number 32. What are the list four specific characteristics of the image of the object formed by a convex mirror? So it's always formed behind the mirror, between the pole and its focus. See, in between the pole and focus, it's the image is always behind the mirror. Please, you have to remember. An image is always virtual and erect. Size of the image is always smaller than the object, and the magnification is always positive. Next question is application question. That's very important. Vehicles is a mirror, and the mirror are the closer than they appear. Why is the warning printed on the side view mirror of most vehicles? So the vehicles in this mirror are closer than they appear is a safety warning printed on a side view mirror and most vehicles. It is present because the side view mirror is a convex mirror and it gives a virtual image, a wide field behind the vehicle and appear the object smaller and the further away than they actually are. The angular size of the virtual image is also smaller than the angular size of the object. During the lane change, a driver assumes that an adjacent vehicle is a safe distance behind. When in fact is quite a bit small closer, the warning serves as a reminder to the driver of his potential problem. Next question is completely direct question that distinguish between the convex and concave. So we know that it's a convex mirror is always forms a virtual image, and it's erect and the irrespective of the position of the object. But in concave mirror is forms a real or virtual or erect, and then inverted image based on the position of the object. Question number 35. Why are we advised not to see the sun directly? Because the strong or intense sun rays will get converged on the retina and may cause fire to burn in the retina, so it's not advisable to see the sun directly. Question number 36 is distinguish between a real and a virtual image of the object. What type of image is formed and by a plane mirror on a cinema screen? So that means the light rays after reflection converge to a point to form an image. It's called a real image, and it's a diverging and form a virtual image, and real image can be obtained on the screen and virtual image cannot be, because plane mirror forms a virtual and cinema screen is a real image is forming. Question number 37. What is the minimum number of rays required to locating the image formed by a concave mirror of an object? So you have to draw a diagram to show the formation of a virtual image by a convex mirror, that its two rays are required. So you can see that the ray is passed through, the ray is going to be incident on the mirror to come back through the focus, and then another ray is also incident to the mirror, and then can be behind the merge behind the mirror, it can be formed on the object. Question number 38. Name the type of the mirror used in design of a solar furnace. Explain how high temperature is achieved by this device. Concave mirror is used to design of a furnaces. High temperature achieved by this device is by focusing the sunlight incident on a concave mirror. It's a focal point. So this section, the questions are all finished, but I told you that. But the 2 mark question will continue. I will upload the next video for that, and then the next page. Actually, I told you that I'm going to show that in 20th question. That's a calculation question, and it's very important. The speed of light in a transparent medium is zero point 0.6 times that of its speed in vacuum. What is the refractive index of the medium? See, look at the question and answer. What they given? You have to look for that. Refractive index of the transparent medium, we know that mu equal C by V. What is C? Speed of the light, in vacuum, and V speed of the light in medium. So, as per the question, you have to read that, because it's saying this, speed of the light in a transparent medium is. See, that means is a V equal zero point 0.6 times of speed in vacuum. So, zero point 0.6 of C. So applying the V in equation number 1. So you have to say that mu equals C by zero point 0.6 C. You can cancel C out. Then you will get 1 by 0 point 0.6, and then make a fraction 10 by 6. You will get, the fraction decimal to convert the fraction 10 by 6. You will get 5 by 3. If you divide, you will get a 1.666. So the answer is 1.6. If you don't know how to calculate this part, please let me know, so you can just ask the question, the same question, or like I can help you. You can just mention in the comment box and I will help you. Next page, I'm just giving you 2 questions. Please do it. This is just like a homework. You can try for that. You can try your best. And if you don't know this, how to do that, then I can help you for this. So this is just practices. So we'll be back on the next video. And yeah, so that's it. And then we'll be back for the next video and tomorrow. And then you have to practice every day. And then yeah, that's it. So bye bye.